Okay. Hello, everyone. Welcome to the first day of our workshop series as part of the CTRL+Hack+ZK hackathon. My name is Vicky, and I will be your host for the upcoming days. Today, we have a lineup of 4 insightful sessions. Feel free to ask any questions. You can do it through the Q&A option. If time allows, we will respond them right after the session. If not, we'll get to them later on our private Discord channel. So let's kick off with our first session by Dennis from Hackathon. Dennis, the floor is yours.
Hey everyone, can you hear and see me? I assume yes. So first of all, I'm like super excited to be honored to kick this workshop series off. I would like to thank the whole athon team and everyone for organizing this hackathon so well. And yeah, off for a great start and looking forward to see all your projects. But first, how can you actually build your project? And that's where my session comes in. Today, I will show you how you can use our boilerplate or our dev tooling to scaffold your full stack application quickly with smart contracts and the front end. I'm Dennis. I'm the co-founder of dApps, the developers behind a0.id, which is the, let me just go forward on my presentation. Yeah. a0.id is the official domain name service on aleph0. It's written in Ink smart contracts. And yeah, you can go to a0.id and try Ink mainnet dApp out yourself. So let's dive into the topic. What's actually a decentralized app or a dApp or an app running on the blockchain? So for me, it consists of 2 different parts. Obviously, the front end and the back end. And with both of them, we try to decentralize those as much as possible. How can we achieve this in the front end? So on the one side, of course, we can connect our browser to the blockchain. We can speak with the blockchain with some kind of wallet extension. We can fetch data from IPFS instead of traditional AWS servers. We can use Light clients to directly connect to the chain instead of RPCs and so on. On the backend side of things, you don't have like a traditional Web2 Postgres or SQL database, but instead you store or you have your storage on the blockchain that can be either with smart contracts or pellets or indexed by an indexer network. Today, I will show you how to do it with smart contracts, which is also the way to go on aleph0. Yeah, no. So why do I think front-end matters? As this session will not only about the smart contract side of things, but also on the front end, how to connect it, how to speak to the chain, how to actually build an UI, an application that's going to be used. Because I think we need like, in crypto, we need 10x better UX to actually onboard the masses, and just like some hacky command line interfaces won't do the trick. And of course, we also need better developer experience to onboard front-end developers. And that's actually what I try to achieve as well with Hackathon, what I will show you in a second. Yeah, and an unpopular opinion I have, good design and front-end work actually takes more time than contract work. Like really, if you count everything, and of course, I don't want to say contracts are like easy, but if you like from building like your first sketches to doing the first UI frames, implementing the front end, having feedback loops, fine-tuning it with your end customers. It's not like you have a smart contract audit and it's done to some extent. But yeah, both. Just a sec. Okay, so let's dive into what tooling actually is available for you guys to start your development journey on Substrate, on aleph0, and on Ink, which is the smart contract programming language, which is based on Rust. So on the contract level, you have Ink itself, which is some kind of like Rust eDSL. You can think of it as some kind of framework or some kind of like functions. You have to remember to write efficient smart contracts, then cargo contract, which you use to actually build these smart contracts, compile them, and you can also use the CLI to deploy it, but I prefer a different way of deployment, which I will also show you later in the talk. Then you have some kind of standards like PSP22 and PSP32, which are ERC20 and ERC721 equivalents on a substrate or an Aleph0. You can go to the just recently announced cardinal cryptography repositories, go through the readmes there and check them out. It's really super easy to deploy your own fungible or non-fungible token. On the node and deployment side, to locally, of course, you can also just deploy everything on Aleph0 testnet, where there's a faucet and you can just claim some T0 tokens to use it. But for development cycle of quick development iterations, I like it to spawn a local substrate contracts node, which is like a very lean or light substrate, reduced version of substrate with just smart contract functionality. Then there's also Swanky, which you could use, which is a little bit more feature complete. For actual deployment and contract interaction or during your development process, you can, as said, use cargo contract. You can use Drink, which I can really recommend to play with your contracts in the terminal. It's by the Aleph0 team. Definitely give it a try. You can use contracts UI if you're more of the UI type or GUI type of person. You can just upload your front-end metadata into the browser and then get an auto-generated UI to interact with each function or perform each query on your contract. And then there's Polkadot.js apps, which is like the Polkadot.js interface, which I don't really recommend to use for contracts. Go for contract UI instead. On the front-end level, there's a base layer library, which is Polkadot.js API, but which is a little bit tricky to use or to set up, or at least it costs you quite some time in the hackathon, which is why I built an abstraction layer for React frontends on top, which is use Inkathon. I will show this live in just a minute. There's also using as an alternative available. For type-safe contract interactions, probably not something you want to do during the hackathon, maybe, but more for production-grade applications. You can check out these two projects. And the boilerplate, which I'm going to present more in depth now, is Inkathon. So what actually is Inkathon? Inkathon is a full-stack boilerplate for Ink smart contracts and a Next.js or React frontend. It's like a monorepo. I will go through the structure right now, but one core pillar of it is use Inkathon, which is the library, the abstraction library on top of Polkadot.js I just told you about. Actually, Inkathon gets used in Inkathon and use Inkathon both get used more and more. It's really has more than 120 dependents on GitHub by now, which is exciting. On Aleph0 on a0.id, our project, it's used by more than 1,000 users. It has 250 stars on GitHub, so you can really be safe using it. So how does the actual stack look like? It's a monorepo structure, which shouldn't sound too complex for you. It's really just two folders, one with the front end and one with the contracts in one repository. You can use either PNPM or Yarn as a package manager with it. I would strongly recommend PNPM because it works the best with monorepos in my experience. You have everything out of the box, like a configuration for your code editor. You don't have to set up ESLint or Prettier or anything. You get Vercel deployment configuration, but if you want to deploy it your own, you also have Docker files. So as I said, two pillars, contracts and front end. Let's dive deeper into the front end side into the contract side of things. Of course, for Ink smart contracts, you need Rust, Cargo, Ink. It's all set up in this directory. There is a shorthand script to spin up your substrate contracts node. There is shorthand scripts to spin up contracts UI or Polkadot.js apps. Nothing too exciting. And of course, there's a sample. There's a sample smart contract in there, which is also pre-connected to the front end, and it's also pre-deployed, but you can also build it your own and deploy it locally, which we also will do live in a moment. And on top of that, there's a real ecosystem, I would say, by now of shorthands or of small scripts, which got really better over time. For example, for deployment, for interactions, for address exporting, so it can be used in the front end very efficiently. So that really takes away a lot of work from you setting everything of these two things up when you're starting a new project. On the front end side, as I said, there's a Next.js application, but it's basically just React. There's no real Next.js API routes or something like this used anywhere. It's compatible with both the pages and the app tier. The main branch is using the app tier structure, but there is another one which is still with the pages tier. There is some basic styling and some basic Web3 components in there, but we really try to stay as opinionated as possible. So you can do whatever you like most. Is it like plain CSS, Tailwind, any other styled component magic, or UI framework even for the sake of the hackathon? Then there's Polkadot.js as like a base layer of front-end functionality. And on top of this, the useInkaton hook library, which abstracts away a lot of functionality, gives you your contract instances across, access to your contract instances across the whole project, and more. So yeah, what's useInkaton really? Like, it saves you a lot of code, like really a lot of. I once had I once had a screenshot here where it really shows the diff of like this long function written in pure Polkadot.js to like 5 lines of code with useInkaton, and really this repeats across the project. So if you have multiple components speaking to the chain, doing queries and transactions, it really pays off to use it. You have to import your contracts and metadata and addresses only once, and can access it everywhere with a hook. You have shorthands for like a lot of basic stuff, and constants for like all the chains and wallets. So it's demo time. Let's get our hands dirty, do a live coding session, and yeah, where to start from? Like, if you remember one thing from this workshop session. Oh, let's go here. Let's actually switch those. If you remember one thing, go on inkaton.xyz. There is like a sample that's like basically the demo of the boilerplate. It's the same you get when you are doing it, when we're doing it locally in a second. And the GitHub README. It's like a great starting point with lots of setup instructions, documentation, how to get it started, how to set up Rust, how to set up the front end, how to customize the project, create custom contracts, deploy it, and even an FAQ at the end. So go through this, and also, of course, always feel free to ask in the Discord, open issues, and so on. So actually, in the live coding session, I would like to start where all of you are starting. We're just cloning this boilerplate. So I will do like a completely fresh project now, guide you through it, and actually get this running. So start by just cloning the repository. Do that however you like, or however you do it. Well, just jump to the bottom. I do it with the GH CLI. So this is ready. I cd into it, and now I can already open VS Code and do everything from here. So I will close the other VS Code window, whatever this was about. And I open, now it asks me if I want to open the workspace in the VS Code workspace file, which has a few nice things with it. You don't have to do it. It works all without it, but I like to do it, and I will show you why in a second. So what you see now, I have the project. That's like really the starting point. I did nothing yet. You have the project root, which is just everything. And then you also have it split into different like workspaces. One is the front end workspace and one is the contract workspace. And this also comes with the nice thing that you can actually, for example, if you do stuff like opening a new terminal, it asks you where do you want to open it, in the root, in the front end, in the contracts. We will just open one in the root to actually install the dependencies. And that's also the only step that's necessary for set up this thing. There are some like very small post-install scripts here which create an empty environment file, so you don't even have to do this. So now the dependencies are installed, and I can do p&pm run dev to start it up, and we will try this out. So already running. So, and it actually was this easy with like 3 terminal commands, like from 0 to have a running dApp locally, already pre-connected to like our sample smart contracts, pre-connected to the aleph0 testnet. And let's go through the UI here, actually. You have like a wallet connect button. Here you can also switch chains. If there are multiple chains activated, you can switch between your accounts. I would recommend like installing like a wallet like Subwallet or Talisman or anything. It's compatible also with Nightly Wallet. You can disconnect. You see your balance. T0 is the testnet token balance, as I said earlier. You have some chain information, the version. You have some shorthand links. They are all pre-configured with the like current chain RPC. So if you click on Faucet or Explorer, it really shows you the Faucet and Explorer for the connected chain. And on the right side, you have the sample smart contract, which is a greeter smart contract. For those who don't know what a greeter smart contract is, it just stores a string. Everyone can update it, and you can read it. That's like the whole smart contract. I will show you the actual ink code in a second. So let's just interact with it. Let's update the greeting to GM Workshop, submit it. Oh, that's the disadvantage of being in full screen mode. I approve it, and it's already done. I will, if I exit this, I will probably also exit the presentation. I will just keep it like that. I think you can figure it out. So the greeting is updated and it's fetched from chain, and if I refresh, it's also it's the same. So it's really speaking to remote smart contracts because we don't have any like blockchain node running locally yet. That's actually what we will do next. But first, let's dive a bit more through the project structure. So start with the contracts. The contracts also have like a package JSON, even though they're not like a JavaScript project, but more a Rust code. But the only reason for this is there are some scripts which are written in JavaScript, well, not here, but here, where you can, for example, deploy stuff, and with all the use hackathon abstractions, which are also used in these scripts, not only in the front end, they can also be used in the back end or in plain Node.js, wherever you like. You see like actually deploying a contract is as easy as like 2 lines of code. And I get the deployment data from the greeter directory, which is under source, where the smart contracts are, contracts, source, greeter. And then lib.rs is the convention how like the Ink smart contract file is named after. So let's have a look at this. It's really like if you will attend the Ink workshop, you will like go more in depth about like what goes on here, but it's really just a Rust module with a few macros on top. Like this is an Ink contract. This is an event defined. You don't even need it for the contract to function. I just have it so it's possible to index it later. You have the storage, which is actually just the string, what I told you about, the greeting, which is like one string, which is like stored on chain by the contract. And then you have the implementation, which first has 2 constructors. One that just like sets up or stores a sample string during construction, and the other one where you can pass a dynamic string. Then we have one getter, which is the greet message. It just returns the string, and we have one setter, which just sets the string. This here just fires the event. You don't even need it. And the nice thing with Rust or Ink smart contracts is you can have like native tests in the same file. So here you see I have a test module, and I actually can verify this by inline clicking these run test things that my functions are working as expected. So next thing I want to show you in the contracts directory is the deployments folder. This is like some kind of like a definition how this folder has to be named and how the contracts are subfolders, and then there are TypeScript files with the actual addresses, the deployment addresses. So for example, here's an aleph0 testnet TypeScript, and this just exports an address where the actual contract is deployed. And the nice thing about this convention is we can have a development TS file, which exports the local node deployment address, and we can git ignore this. So you don't have like, if you're working in a team, you don't have merge conflicts, like everyone deploying locally, of course, don't have deterministic contract addresses. This would like create a mess. And what's also in this folder is the contract metadata, which is used by the front end to actually build up calls in a like typed manner to like speak to the RPC. That's what Polkadot.js is doing under the hood. And this is actually also where the beauty of this whole boilerplate comes in. So you actually like can do everything with your contracts here, but like the front end automatically is importing all what they need from the contracts directory. So you don't have like one contract project and one front end project, and then like you send or you copy and paste addresses, you copy and paste metadata, and you have to do this in development, in quick development cycles. You have to do this like 100 times a day, which gets super annoying, error prone, and also like it's just like programmed to there will be bugs. So what to do next? As I said, we now want to connect our like dApp we have running to a local node, which I also just will start. And then I will like build the contract and deploy the contract on this local node. And then I will connect the front end to that local node. It sounds like a lot, but you will see this is super easy. Let me close these. Let me spin up another terminal in the contracts directory. We have one here. So what can I do? I can just use one of the shorthand package JSON scripts, and one of them is build, which will just do the cargo contract build command. You can like check this out yourself. It's really no magic happening here. And after it has built the contract, it will move the correct artifacts to this deployment directory I showed you earlier. So let's wait a second. Live coding, especially with Rust builds, is always risky, but I hope everything works. Still confident? Yep, it built everything and copied the build files here. So now let's spin up a local node, which is done by pnpm run node, which is a shorthand for substrate contracts node. How to install this? It's all written to README. It's really and it's also persistent. So it's like defining this node data, gitignode node data folder where it stores all the node data. So you can like stop developing today, shut everything down, come back tomorrow, and all contracts are deployed at the same place, and everything is just there. Now, of course, you need to like let the local node running. So I open another terminal in the contracts folder, and I will do pnpm run deploy, which kicks off the deployment script I showed you earlier. So really just this small function. You see, it deployed the greeter contract under 5C.wf. And now it exported the deployment file here. So let's have a look at this file, and you see it's 5C.wf. So how to tune the front end or modify the front end to speak to the actual local node. That's very easy. There's an environment file, the one I told you at the beginning, which was created where the default one was created when I installed the dependencies. It has like one chain variable here, which is set to Aleph0 testnet. And you can find all the identifiers also in the README. And I can just like swap this out with development, save, go to the front end again and refresh. And now you see 5CWF is the like contract address we are speaking to. You see we are no longer connected with the Aleph0 testnet, but with the development node, it's now all locally. And you also see it's like the default Hello Inc. Value, which was set in our constructor and not the one from the live deployment. So let me update the greeting, but this will not work now. Why? You see this like little exclamation mark here. I actually don't, because I just spin up a completely new local node. Of course, my currently connected account doesn't have any funds yet. So I need to pay gas to do an actual transaction to change state on a blockchain. And this is what I need to get now. How do I get this? I click on the Explorer link, which automatically opens Polkadot.js, pre-configured with my local node RPC. So this is speaking to local node. If you are using Brave like me or like me normally, you have to like set up, shut down the guards and allow something that like actually they can speak to your local WebSocket instance. Go to accounts, transfer, and now ask Alice. This is just like a substrate convention. Alice always gets pre-funded with like an infinite amount of money almost, and you can use that and send it to your own account. Let me send 100 units. make transfer, sign, and go back. And you see, I already have 100 because your hackathon hooks are configured to like automatically watching the state and update the balance without a page refresh. I can update the greeting now because I have gas. Hello, submit. Subfolder is opening, approve. And it's updated. So now I have updated my local node chain state. And as we only have a couple of minutes left, I hope it's not bad if I do like a couple of minutes more. I will show you a little bit more how the front end works, because that's, I guess, super interesting for you if you want to build an actual application during the hackathon. So as I said, it's like a Next.js application. Some config files at the root, can mostly ignore them. They are set up perfectly fine. So ESLint is working, Prettier is working, Next is working, Tailwind is working. And under the source folder, we have an app folder, which is like even more interesting, which I show you first, is the deployments folder, where there's one single deployments file. And this is actually doing what I like specified monorepo magic earlier. It's importing dynamically the contracts and the metadata files and the addresses I need from the contract subfolder, like hackathon contracts, deployments, the folder I showed you earlier, contract ID, greeter. In this case, you can also add some or remove or rename or whatever. And then it checks for the network. Where's the network defined? You also have seen this in the environment file. You can also define multiple ones. And yeah, it's loading the metadata JSON. But where does this deployment object created from here gets fed into? It's in the provider. Like in our like layout, we have wrapped our children in some client providers, which is specifically the use hackathon provider, which you'll also find in the docs. It's like super easy to configure it, give it the chain from the environment and the deployments from the function I just showed you. And what this does is like it provides you with the deployments across your whole dev. For example, I will show you a few components. There is the chain info component, for example, which is, let me go back, this thing here, chain info. You can use the use hackathon hook here to get the active chain or get the IPI. And then I'm fetching some chain info here and displaying it. And on the greeter contract interactions, which is like this side of the UI, you can use use registered contract, which is like a second hook by use hackathon, to like just access the greeter. This is like type safe because I'm accessing this enum I'm defined here. And I have the contract object, which is the contract.js API contract promise, and I have the address. And even if the user switches the chain, updates the contract and the contracts directory, or does anything, all of this gets updated automatically. You don't have to do any if and else, if the chain states, if like the environment changes, or if the address changes, gets redeployed. It's all like happening dynamically, as you just saw. I could also do like a redeployment right now. Why not? Why not? Let's do it. npm run deploy. It's now under 5CRD. Let's refresh the page. And it's now 5CRD. So it's all super dynamic. How is the chain accessed? And these are also the last things I will show. This one is doing a contract query, which means reading stuff from the chain. It's reading from the greet method, which if we go to the lib to the smart contract again, you see the read function is the one that just returns the message. So I'm reading the message with the contract query helper, also from the use hackathon library. Then I decode the output, and that's also is the other stuff is just like boilerplate around, which shows errors, does a loading indicator, and so on. Down below, sorry. So this is like feeding this little input field. Down below, you see I can update the greeting. So that's what this function does. This is like using the contract tx function. Contract tx with toast is just like a little extension that shows like in the lower right, shows like a loading indicator or shows some error messages. For example, if I'm like using another account which has no value, and I said you earlier, if I have no value on a blockchain, I can't transact anything because I don't have gas. If I do this, like the contract TX with Toast will just handle this for me and say insufficient balance to pay for fees. Here I'm using the set message selector, which is this one. You can also use the underscore syntax if I remember correctly. It's up to you. And it's also just boilerplate handling like error states and loading states. Down below, there's a super simple UI for like the UI. I use as I said, stay as unopinionated as possible. It's using like vanilla Tailwind and some Shadcn UI components, which you find here, but they are really just, they're like unmodified. They're like downloaded like from Shadcn UI. If you don't know Shadcn UI, it's great, very unopinionated. You can extend it, change it your own. It's just like basic Tailwind UI. So that's really not very complex. Yeah, that's already it. Like if you want to like play something around with it, I don't have time for this now, but you can do this in the repository. If you download the monorepo down your own, you have like in the project you have like snippets, which are workshop code snippets. This is like can be considered as a homework. If you have never like built your dApp, you just try out this. Like you can really modify the smart contract, redeploy it, and add a function in the front end to access it. It's basically for the reversion of the greeting. So if you just type in workshop snippet, it's get auto-completed. You get like a reverse message function, and then go into the contract interaction, greeter contract interaction component in the front end. Type again workshop. You get like a nice snippet which reverses the greeting. And you get like here down below a nice button. So that's all. Just like you have in between, you have to build the contract again and deploy it again because you changed the contract. So great. Let me head back to the presentation, which also comes to an end now. And yeah, if you have any questions or if we have time for them, I can answer them now. Otherwise, I will be there in the Discord as well. Yeah, and also like if you're looking into integrating A0ID, like the domain service, definitely stay into the call as my colleague Nimish is going to present how you can do this.
Exactly. Thank you, Dennis.